Hello Internet and welcome to a new video. Today we're going to talk about data. The question we're going to answer is what the hell is data? Because we need data every day in our life. So data is, according to Wikipedia, individual facts, statistics, or items of information, often numeric. And if you are, like I am, a data scientist, or you are a data engineer, or whatever, you are interested in artificial intelligence, you understand that this is the future of commerce. Then you might say, how do I get the data I need, for example, for AI? And here for artificial intelligence in natural language programming. And the good thing, there is a pile. There's a big pile, and it is called the pile, an 800 gigabyte dataset of diverse English text for language modeling, especially for LLMs, large language models. And maybe you're familiar with GPT-3 and you have heard about the problems they encounter when it is about some bias, some racial or ethnical bias. This is exactly why data, the input to your system, is so important. But let's go step by step. At first, the pile, an 800 gigabyte data set. What does it consist of? Well, this is rather easy. We just have here a beautiful publication from the authors, and you can see the pile here composed by category consists of some biomedical data, of some law data, all English sentences, of some information about the US patent application and patent office, of some mathematical, physical, and computer science preprints here archived. Then we have some philosophical information. And of course, we have the huge sector of scrapped internet pages. So all the open internet, every beautiful comment, if you have read Reddit comments or have read some other comments, all the beautiful things that the highly intelligent people write in answer of some publication or some whatever is here in our green sector. If you look here at Wikipedia, all of Wikipedia is included. And then you have some library stuff, and you have all of GitHub, some mathematical, you have all YouTube subtitles in it. And all in all together, you have an 825 gigabyte English language dataset for language modeling. This is it. This is the standard dataset you will use when you start with NLP, using LLMs, using large language models. And to come up to the epical pyramid equivalent of human mankind in 2021, I have here an article published in October 11th, 2021 by Microsoft Research. And they built the largest and most powerful language model in the world. They call it the Megatron. If you have seen some Transformer movies, you know what people are working at Microsoft. The Megatron-Turing NLG 530B. And if you're wondering what 530B means, if you're familiar with the GPT-3, you know that we're here in billions of parameters. And yes, you're right, this is about 530 billion parameters, open parameters that you can tune in this model. And you might ask, hey, if I have 530 billion free parameters and I'm free to program this model and tune each and every parameter, 530 billion functions, I mean, what can this model not do if you compare it with the size of the human brain? Well, you will be surprised because we have here a 105 layer model. We have about 20,480 hidden dimensions. And of course, we have our classical 128 attention heads. So this is the model. We have the data set, The data set is 800 gigabyte, almost close to a terabyte. We have a huge model that we train our input data set on. We have, of course, a transformer-based NLG model. And then if we compare it, here you have on the x-axis the time, 2021. You have here the Megatron-Turing NLG 530B, almost close. Ah, that's nice. To the end of 2021, we have here in October, Microsoft has this model. And you can see it has 3 times the free parameters of GPT-3, which had only a lousy 175 billion free parameters to play around with. So here we go. Please, I want to go back. Hold on a second. Yeah, here we are. So let's look. We have the data set, we have the software. Now we have to look out for the hardware to run our models on. And what a coincidence, there is a partnership between a little company called Microsoft and a little company called NVIDIA. And they partnered to build a little supercomputer like NVIDIA Selene. Now, NVIDIA Selene, you might say, okay, so this is this pocket-sized something comparable to a Tesla D1 chip. No. The performance from 0 to 60 miles per hour is with Selene a catastrophe. You could already call it a standstill, technological standstill. But if you're interested, Selene is one of the supercomputers powered by 560 DGX A100 servers. Now you know that each DGX A100 has 8 NVIDIA A180 gigabyte Tensor Core GPUs, so quite a lot of GPUs working there to achieve the training of this model. And as they told us, they started with 280, then 350, and finally 420 DGX A100 servers to run this model that they developed. And the iteration time was a mere 45 seconds. But if you think that almost all of one of the biggest supercomputer on Earth took almost a minute to calculate, you can see how relevant this calculation is for the typical small and medium enterprise, for the mom and dad shop somewhere in Iowa that really will be able to utilize the technological finding and the innovation performed by this company. So in no way this is something where the primary cloud companies like Amazon, Google, and maybe Microsoft will take advantage that you can run Microsoft Office on more than 2000 GPU accelerator. This is what I've been looking for my Microsoft pad. So, coming back to reality, you will ask yourself, okay, this model has been trained. It has been trained in a ridiculous short amount of time instead of weeks and months running in the cloud. It has been trained really fast if you occupy a whole supercomputer data center. But what is the task? What is the benchmark? What is the reason why they did it? What was the question giving to the system? And here we have now from the official Microsoft, just to show you, Microsoft research blog in October 2021, we finally get some insight to the question they asked this supercomputer after spending, I don't know, hundreds and millions of dollars. And it is at first inferring mathematical operations. So you were given a sample of this, and then after having been trained for a long time on the highest software and hardware configuration on this earth in a supercomputer, you are asked the following question. 45 and a mathematical operator, I will not specify, at 5 equals what? And you will not guess it, but the system was able to come up with the answer 9. So given just this set of example to learn on, 11 by a numerical operator, an algebraic operator, let's say it is divided by 2, is 11 divided by 2 is 5.5. And then we have the operation 18 with an to be defined operator 9 equals 2. 9 times 2 equals, you will not believe it. And this system, after spending hundreds of millions of dollars, maybe even more, when you started to ask the question, 45, an algebraic operator, 5 equals 2, and the system answers you without having studied a single book. Oh, well, yeah, in Wikipedia, of course, there was algebra. They could tell you it is 9. The mathematical operator has a high chance of probability to be divided by. So, this is the kind of answer. This is the mathematical ingenious concept, the answers that they found, providing all these models. And of course, there's not only the advantages of this model, because, I mean, if you are familiar with algebra and you had a Texas Instrument calculator, I don't know, from the 1980s, 1982 was mine, I suppose, and you just type 45 divided by... No, this is about something completely different, and we have a problem because of the gigantic language model and the text that we used as an input. And remember, there was maybe some Reddit comments or some general comments from some very nice people on the internet that had an absolutely scientific view about, I don't know, politics, or about some virus, or about the intellectual capacity of their neighbors, whatever. To our amazement, we have bias in our language models. So this means that, as Microsoft stated, our observation with NLG are that a model picks up stereotypes and bias from the data on which it is trained. Now, this is amazing. Can you imagine, without having trained philosophy and moral theory to this computer, they still pick up human stereotypes from, I don't know, what, 800 gigabytes of human data, human comments, publication, and discussion on the internet. They pick up stereotypes. This is amazing. An unforeseen consequence, maybe a negative consequence, but do not be afraid, because we have Microsoft responsible AI principles. And those principles emphasize fairness, reliability, safety, privacy, security, inclusiveness, transparency, accountability, are considered to be key cornerstones of approach to develop and use AI. What does it mean for the bias we have here? This will be revealed to us in a new research blog by Microsoft, I suppose, but for the time being, let's summarize. We have a data set with 800 gigabytes of diverse English text. We can use as an input model, an input data sequence of English sentences. And these English sentences are our hero set, data set. Everything in this data set is what the system tries to emulate. The system tries to learn each and every sentence, each sequence, each sentence, and it uses quite a heterogeneous set of data for this. We have hardware. We have models trained on the hardware, like MT-NLG 530B, the largest LLM that we ever encountered on this planet. And we got to these amazing answers to the question that were in our mind for quite some time. I understand this. But you see, this is the state of artificial intelligence now at the end of 2021. And I hope to show you one thing. Data is the beginning of all artificial intelligence. If data have some bias, if the data you feed the system and you tell the system that you have to simulate exactly each and every sentence, each and every sequence of words of those sentences to be able to behave like a human, you will get the full characteristic of the human race. You will not only get the good character and the honesty of the people, but you also get what is an inherent part of all of us, the yin and the yang of our being. So do not be surprised if we use the latest technology, the biggest hardware infrastructure for AI, that we succeed in simulating human behavior, the expression of human beings. Don't be surprised if it really mimics ourselves very, very well. Thank you to listening and watching this video, and I tell you the next video is already in the making, and be amazed what I will come up with next week. See you, and until then, bye bye.